Hello everyone, today I'm going to talk about how to do logistic regression in R. Logistic regression involves binomial response data, in which there are only two outcomes, generally assigned to a 0 or a 1. For example, presence or absence, yes or no, correct or incorrect, or some other categorical variable, such as male or female, dispersed or stayed. Simple logistic regression uses a continuous predictor variable, such as year, time, and temperature. Let's look at an example in R. First, I need to load in the necessary libraries, which in this case is ggplot2. Then I will set my working directory. My data is looking at whether a brown-headed cowbird is present at different sampling sites. For each site, I have data telling me the composition of the land cover in terms of percent. So I know the percent impervious, agricultural, forest, and wetland cover within my sampling regions. I've read papers that have said that the brown-headed cowbird presence is positively related to agricultural cover, so I want to see if I find the same trend in my data. Thus, my predictor variable is going to be the percent of agricultural cover, and my response variable is the presence-absence of the cowbird for each sampling site. Let's read in the data frame called cowbird env and call it df for data frame. Let's see what my data frame looks like using the head function with our data frame name in the brackets. This outputs a snippet of the first few rows of our data frame. As you can see, we have the cowbird presence absence labeled as CBPA and different land cover types. Presence is denoted with a 1 and absence is denoted with a 0, and our land cover percentages range from 0 to 100. Then I'm going to NA omit our data frame, which removes any rows where the presence-absence data is NA or unavailable. Now we can visualize our data with a ggplot. Let's write ggplot, the name of our data, and then the aesthetics information. This sets x equal to agriculture and y equal to CBPA, the presence-absence of the cowbird. Then we include geom point, which displays each observation. I additionally choose to include geom jitter, which is optional, but offsets the points a bit from each other so they aren't directly overlapping on 0 or 1. To create the logistic regression line, we use geom smooth with the method set to glm, and it is important that the family is set to be binomial so it registers that we are doing logistic regression. I included other optional steps to customize the final plot a bit more. Scale X continuous and Scale Y continuous allow you to customize the X and Y axes respectively. For the X axis, I created a custom axis title and defined my limits as 0 to 100, the maximum and minimum of my range. To avoid clutter on the X axis, I defined the breaks, which are the tick marks on the X axis. I decided to define them in increments of 10 rather than to include every single digit. Similarly, for the y-axis, I created a custom title, Probability of Brown-Headed Cowbird Presence. This is what the regression line is going to show us. With an increasing proportion of agricultural cover, how does the probability of the cowbird presence change? Additionally, I included some other elements to clean up the plot by making the background solid white with a black outline. Now we can run the plot and allow it to render. Don't worry about the missing values error at the bottom. It is just telling us that not every single point is shown on the plot because we had such a big data set, which is okay in this case because I'm not super interested in the points themselves, just the general trend. When it comes up, we can see the jitter points that are slightly offset from each other, and we can also see our regression line with the standard error shading. As you can see, the probability of brown-headed cowbird presence seems to be positively related with the increasing proportion of agricultural cover. But now we want to see if this positive trend is statistically significant. So let's move the plot out of the way for now and run a statistical analysis. Now we want to run a generalized linear model, or GLM. The formula is GLM, your y variable, which is the response, and then your x variable, which is the predictor, the data frame, and then the family. Since we are doing logistic regression, family is binomial. For the y, we can replace it with CBPA, the cowbird presence absence, and for the x, we can replace it with agricultural percent. I'm going to name this model and run it. To test the significance of the model, we can use the drop1 function. This uses single term deletions, so it deletes one term at a time to give you the significance of each individually. This is especially important for models with multiple predictor variables and interactions between them. So not super helpful in our case, but I'm showing you how to do it for bigger models. For the test, we set this to chi-squared and can see that the result is less than 0.05, so agriculture is a significant term. We can also run the summary of the model, which also indicates that agriculture is significant. Here we can additionally look at the estimate, and since it is positive, we can see that there is a positive relationship between agriculture and cowbird presence. Here the estimate tells us that with every 1% increase of the agricultural predictor, the probability of cowbird presence changes on average 0.025 in the log odds of taking on a value of 1. To summarize, today we plotted a logistic regression curve and ran a statistical analysis of the model in R. Check out my page if you're interested in more video tutorials on R or QGIS. If you have any other questions or suggestions, please put them in the comments. I hope you found this video helpful. Thank you for watching.